Is it recording? Yep, it should be recording.
I think so, yeah.
We're good.
Alrighty, so we'll jump right into it. Oh no. Oh, there we go. There we go. Slide. Okay, so cool. I'm gonna go to the next slide. So what is ASHRAE? A lot of you probably already know what ASHRAE is because you've come out of other chapters or you're familiar with the name, but just in case you don't, ASHRAE stands for American Society of Heating, Refrigerating, and Air Conditioning Engineers. They mainly focus on building systems, energy efficiency, indoor air quality, and sustainability within the industry. So that's anything from HVAC to net zero building and everything associated with mechanical and civil areas, and even electrical. And they have university and city chapters all across North America and around the world, which is really cool. Last year I went to a conference where I met lots of people who were from different chapters from across North America, across the world itself. And it was really, really cool to see a lot of different people all coming together to get involved in a common goal. And also they help students develop professionally and personally. And that is one of our goals for this year. We want to help you guys develop personally as like through research and through the things that we're going to present to you to give you more knowledge and insight. And also we want to help you develop professionally and allow you to have opportunities for networking. We have some people here tonight who I know are very into that, and you can contact them once you get more into the club, but yeah. And then I'm just gonna go over our values. So for ASHRAE as a club, we want to create a safe space. We want to create an environment for members to learn off each other, support one another, and have a good time doing it. So if you guys have any questions throughout the entire presentation, feel free to raise your hand, turn on your mic, and ask them. Our second value is sustainability. So we really want to focus on serving the built environment. We want to shape a more sustainable future, and we're really interested in learning about more sustainable HVAC designs. And lastly, we are super big into networking. We want to reach out to more chapters this year, build lasting connections with ASHRAE community and the industry because it's extremely important and a huge part of ASHRAE. So the reason that we're all here is to talk about HVAC and R. So what is that? Well, I mentioned before, ASHRAE Society of Heating, Ventilation, Air Conditioning, and then the plus R is Refrigeration Engineers. And so basically, HVAC and R is essentially indoor heating and cooling of buildings, airflows, and the preservation of air quality indoors, which right now is extremely important because COVID, and people need to be making sure that buildings are properly ventilated in order to keep everyone safe. So an important system that dictates a building's efficiency and also in turn its cost. Monitoring HVAC and monitoring refrigeration is a super important part of a building system, and it contributes a huge amount to a cost of a building. So today we'll be covering 4 main topics. So the first one is heating, the second is ventilation, the third is air conditioning, and the fourth is refrigeration. So basically, we're going to kind of go over the main points, and then we're going to go more in depth and talk about some interesting concepts that a few of our research team have came about on their own out of personal interest to share with you, and then we can kind of have like a conversation after each person has shared what they learned and wants to share with you guys. So with that, we'll get started with heating.
Oh, so yeah, as Margot said, I'm going to be talking about heating. So we know heating, especially in Canada, is very important, and it's required to provide a thermally comfortable environment in the building, especially in like the winter months, but even sometimes in the summer. Usually when it's below about 18 degrees, you need some heating. It works by either distributing hot air or hot water around the house, and it tends to be pumped around the space so that everywhere can be heated to the same level, so you have comfort, everywhere in a space or a home. in particular, I wanted to focus on this diagram here, which is a really clever way to heat a home called the heat recovery ventilator. So this takes stale indoor air and expels it to the outside. But while it's doing that, it takes the heat from the indoor air and uses that to heat fresh air that comes in. And then this new fresh air is then expelled into the indoor environment, meaning that it can heat the indoor space without actually needing to use any energy to heat the air. So this is good because it reduces the build heating costs, because obviously you don't need to reheat, you don't need to heat the new warm air, but also it lowers the air humidity because you're constantly getting a cycle of air. And then it also, especially, which is important now, gets contaminants out. So, reduces the level of spreading a disease like COVID. So yeah, so this is like a really clever way and a sustainable way to heat a space.
Cool. So next we'll go on to ventilation.
Yeah, so I'm going to be talking about what is ventilation. And the most basic definition is that it's a process inside of your house that replaces the outside air outside air with indoor air. And it then circulates it around and keeps the air fresh. And ventilation is an important part of HVAC because without fresh air, you'll feel really uncomfortable, and air around you can have lots of toxins and contaminants that would make you sick. And there are two main types of ventilation. The first one being mechanical, and this is essential for modern types of homes and commercial buildings that want to be energy efficient. And basically it's the usage of ducts and fans to draw in fresh air. And a common household example of this would be the kitchen exhaust fan on top of your stove, which exhausts the fume and smoke coming out of your kitchen. And the main advantages of mechanical ventilation would be that the airflow is regulated and it's controlled by the user that's in that area. And the main disadvantage would obviously be the installation and maintenance costs that would be involved. And the second type of ventilation would be natural ventilation. And this is where outdoor air is pulled in through a building. And this is caused by temperature differences, causing a flow of air throughout the building that removes unwanted warm air. And on the right, you can see a diagram of this that I put in. And basically, every time you open the window, this is an example of natural ventilation. And this is when you air your house out. So the main advantages of natural ventilation would be that there's little to no operating cost to open a window. And there's also humidity control, since it provides continuous airflow throughout the building that can help reduce the humidity. And the main disadvantages would be that the airflow outside is pretty unpredictable, and it also depends on the outdoor climate. And also this is less effective in winter because buildings would need to be tighter. And finally, there's mixed mode, which has a combination of natural and mechanical ventilation. And it switches between the two where it uses mechanical when the natural ventilation outside is low. And that's it for ventilation. I will pass it off to whoever's next.
That's me. Okay, so I'm going to be talking about, if Margot, you could change the slide. Beautiful. I'm going to be talking about ACs, air conditioning, our holy grail during the hot summer days. So yeah, before ACs were actually built or existed, homes were like built a lot higher and like had a lot of breezeways. So like it could like cool the place down, but then ACs entered and just changed the whole game. So we kind of know the like purpose of ACs, but like how do they actually work? So a lot of buildings will have like sealed windows, sealed because if they were open, otherwise all of the cold air would go out and it'd just be counterproductive. So yeah, they'll have sealed windows, and the fresh air from outside will actually go through the vents directly into the AC unit, and then mixing in with the return air. So yeah, that's kind of sick. Yeah, the removal of like the actual heat is through like a refrigeration system, like refrigerants, which Ashley will be talking about in a bit. But before we pass it on to Ashley, I'm going to be talking about ice-powered ACs, which is something I personally didn't know of, but I learned of recently. And basically, ice is used as like a thermal storage, like thermal energy storage, and it essentially like cools down the AC. So basically, ice is made overnight by freezing the water that surrounds like copper coils in the AC unit. So this ice is stored overnight, and then the next day it like melts and cools down the refrigerant. So instead of cooling down the unit's compressor, the AC unit's compressor, it cools down the actual refrigerant, which is cost effective, cheap. We love that. And then it's also energy efficient, which is also great as well. So yeah. Oh, fun fact. Movie theaters back in the day, like used ACs to like market their movies and stuff, like use ACs for marketing. And that's where the term summer blockbuster came from. So yeah, that's air conditioning.
Bit of a pun right there.
Yep.
Alrighty. Okay, Ashley, your turn.
Okay. So this is refrigeration. Annie sort of touched on it a bit before, but I will tell you more about it now. So basically, you could have a cooling side and a heating side, based on which was previously based on gas compression technology. So on the cooling side, the refrigerant is compressed, and then the heat can get expelled from whatever area you're trying to cool down. And then in heating, it's the opposite, where the refrigerant gets expanded. So then the heat from the outside can come into the space that you're cooling. These refrigerants that are used to cool or heat the spaces have large impacts on the global warming and ozone depletion. So generally we want to keep away from that, especially since the systems we use aren't 100% like leak proof, and a lot of the refrigerants often get leaked into the environment. So a better solution for refrigerants would be magnetic refrigeration. So magnetic refrigeration requires metals with large magnetocaloric effects, which is related to the property of exotic materials. As you can see from the right, that's a picture of gadolinium. And basically when you want to cool down a space, the metal is demagnetized, so it's removed away from the magnetic field. And then in heating, the metal is moved into the magnetic field, which is called magnetized. So an example of how it works is in heating, it orders the magnetic domains within the metal, and then the temperature increases as the metal loses some of its ability to hold the heat. Yeah, so in the basic schematics is on the diagram there. And the limitations of this is that it is relatively small temperature differences can only be achieved between the cold and the hot source, which means that you would need to find a better solution to, make sure that you effectively and efficiently use this technology. So a solution for that is to use a heat transfer fluid, which can be water-based, and you don't have the problems that you would have with regular refrigerants, which use fluorine gas as like the main component. So the advantages of this are that it's zero carbon technology, and there's the potential to reduce energy by 30%, which is really great. And then there's no potential for refrigerant leakage, as I said before. And hopefully this can bring us to the government's goal that in 2015 will be carbon net zero. But some of the challenges are that there's a scarce supply of these really rare materials. So that, hopefully by 2015, the market development will be a lot better for this technology, and we'll be able to reap the rewards. Yay.
Alrighty. So I guess a couple people joined throughout the meeting, and I just want to say that we're recording it, so just so that you're aware. Also, if you want to rewatch it later, you can. But if anyone has any questions right now, feel free to put up your hand and turn on your mic, and we can answer them. Or if you're just interested about ASHRAE in general or anything to do with the club, feel free to put up your hand.
Maybe it was just so clear and to the point that no one has any questions. That's cool too. Oh, the recording. I am currently recording it, and then we're going to be sending in the link for general members so we can receive your email and stuff, and then we'll be giving the recording through that email to you guys there, if that makes sense.
Alrighty. So basically, if you're interested, sign up for the ASHRAE International and ASHRAE Toronto memberships. So we have the potential to reimburse these memberships. If you're interested, please send us a message at ashraeutoronto.school.ca first. Or you can just message us once we get your email contact. So by adding your name to the general member list, which we have on our Instagram at ASHRAE UToronto, we'll send you upcoming workshops, networking links, and online tours so that you're able to know when they're going to happen. And also you can follow us on ASHRAE as well while you're there getting the general member list, and also ASHRAE UofT on Facebook. And also feel free to reach out to us if you are interested in us holding any specific tours or learning about any specific topics, because we want to hear from you and we want your feedback, because these workshops are for you guys to learn more about ASHRAE. The end goal for this whole thing kind of was to potentially do a design competition in the spring. So by coming out to the workshops, you'll be learning valuable information that will help you in the future months. And also it's just a good opportunity to learn more if you're interested in HVAC and ASHRAE. So thank you for coming out. It was really great to have this many people show up, even though we kind of got frazzled and had to send out a new link and everything. So it's really great to see your faces. If anyone wants to say anything, go ahead, or you can comment in the chat if you want, if you'd rather, instead of speaking into your mic.
We also want to say, like, we would love to like get like topic submissions if you guys are genuinely like curious about anything. But yeah, it's basically what we have to say. If you guys don't have any questions, feel free to leave. We know it's things with school are getting busy, so we really appreciate for having you guys being here with us today and everything. Should I stop with the recording? Yeah.
Yeah, probably.